Ready?
Mm-hmm.
In this video, we're going to talk about mapping stoichiometry. Stoichiometry. And the reaction we're going to use is the combustion of methane. So methane reacts with oxygen to make carbon dioxide and water. And we know that everything reacts in mole ratios. So for every 1 mole of methane, we're going to use up 2 moles of oxygen, and we'll be able to produce 1 mole of carbon dioxide and 2 moles of water. So in this problem, we're given that we're reacting 32 grams of methane with 160 grams of oxygen. So what I'm going to do is write down how much of each reactant I have in grams in this case. You could also be given later on in the year liters or a molarity and a volume of solution. But for now, we're just going to do grams. So we have 32 grams of methane and we have 160 grams of oxygen. All right, now whenever we're comparing different substances, we have to use moles. Moles allow us to relate the unimaginably small world of atoms to something we can actually measure, like grams. So we're going to go and take a trip to Mole Town. So if we have 32 grams of methane, in order to figure out how many moles that is, we have to divide by the molar mass. Since methane has a molar mass of 16, we multiply this by 1 mole, 16 grams, and that would mean we have 2 moles of methane. Now, for the oxygen, when we're converting that to moles, 1 mole of oxygen, and keep in mind this is a diatomic element, that's going to weigh 32 grams. So that means we have 5 moles of oxygen. So there's 2 ways you could approach it from here, and I'm going to approach it one way and I'll talk about the other way after. I think the easiest way to go about and figure out what's going to limit how much product you can make is to figure out how much you can make with each reactant and then say, well, which is the lower number? So in this case, we're going to take 2 moles of the methane and we're going to figure out how many moles of CO2 we can make from that. Since we get 1 mole of CO2 for every 1 mole of methane, from our methane we'll be able to produce 2.0 moles of carbon dioxide. Now, from our oxygen, where we have 5 moles of it, that reacts in a 1:2 ratio, meaning we get 1 mole of CO2 for every 2 moles of oxygen that we have. So from the oxygen, we would be able to make 2.5 moles of carbon dioxide. So we're going to have to use methane as our limiting reactant. And the example we used in the homework video last night was that we were making bikes out of wheels and frames. And we said if we have 10 frames and 16 wheels, how many bikes can we make? And the answer is 8, because the wheels will let you make 8 bikes, the frames would let you make 10, so you have to go with the lower number. And then once you have that, you can convert that back up to grams by multiplying by the molar mass of carbon dioxide, which in this case, well, in any case, it's 44 grams per mole. So if I'm able to make 2 moles of carbon dioxide, and its molar mass is 44 grams per mole, that means that we could make 88 grams of CO2, and that would answer the question. The other way we could go about this is calculate how many moles of each reactant we have, and then say, how much of the other one would I need to react with that? So for example, let's say I started with oxygen, and I was like, okay, I think this might be the limiting reactant, let me see. You would say that this reacts with, for every 2 moles of oxygen I have, I'm only going to need 1 mole of methane. So if I'm using 5 moles of O2, that means I would need to have 2.5 moles of methane, which I don't. So that would tell you right here this is the limiting reactant, and then you can move forward with that for the rest of your stoichiometric calculations.